This is Algebra Lesson 4.2. Here's the warm-up graphing some different lines. Our objectives today are to be able to draw a line that fits a model or a set of points. Also writing a slope-intercept equation that fits real-world data. So first off, we're going to start talking about writing a linear equation that fits data. When you plot real data, it's not going to be perfect. It's not going to fit an exact straight line, but it will often be in a linear pattern. Based on that, you can figure out predictions based on your previous data, what's going to happen or what would happen. Now again, because it doesn't fall exactly on a line, we have to do what's called a line of best fit. Now a line of best fit is going to follow the pattern of the data, and it's going to go in the same direction, and it's going to be really close to a lot of the data points, but it's not going to be exactly touching every single point. So looking at this graph, which one represents the line of best fit? We're looking for a line that follows the pattern and that has the same idea of a slope or rate of change as a majority of the data. It does not matter how many data points it hits. So thinking about that, line P would be the line of best fit in this case. You can see a majority of the points go in an upward fashion. As you go over to the right on the X, it is going higher on the Y. Line Q is showing a downward slope, which does not follow the pattern of that data set. In example A, we have a table showing how many fat grams are in some hamburgers. Now looking here, we have saturated fat and total fat grams. So over here, we're comparing saturated fat as our X values and total fat as our Y values. And you can see that the line or the data does kind of go in a linear pattern. It's going up and to the right, which means the more saturated fat, the more total fat the hamburger would have. Now the first question is going to ask us to write a linear equation that models this data. Now in order to write in a linear equation, we first need to figure out the slope of the data. When you're using real-world data, you get to decide which points you'd like to use as your slope points, the ones you find the rise and the run between. So let's take a moment and look at our data points and kind of pick out some points that we would like. Now if you notice on my graph, I have 2 points that are listed in red. So right here and right here. And I've circled those ones on our table. So using those 2 points, we're going to calculate the slope. So first I'm going to take 40 and 96 as my x1 and y1. And I'll take 8, 21 as my x2, y2. Now I could reverse those if I wanted to. The order doesn't really matter as long as you stay consistent. So now to put it in my slope equation, I'll do y2 minus y1 divided by x2 minus x1. And I want to simplify those 2 values. So 21 minus 96 comes out to negative 75, and 8 minus 40 comes out to negative 32. Now the negatives do cancel out, but you can figure this out as a decimal if you don't prefer the fraction. So when I look at it as a decimal, I get 2.34375. Now I could round this so that I have a more reasonable number. So maybe I will round it to 2.34. That seems like a nice number to go with. Okay, once we have our slope or rate of change, we also need to know our y-intercept. So I'm going to go back to our graph. I'm going to take my straight edge, and I'm going to connect those 2 points that I used to find slope. So those 2 red points, I'm just going to connect with my best straight line that I can. All right, now what I want to look for is where does that cross the y-intercept? So looking right here, that value right there is what I'm looking for. So I can see that this is about 10 here at that line. And this one doesn't look quite halfway up, but it's pretty close. So maybe we'll say that's 5 for the y-intercept. So if I go back down here, I've got my slope, and I also need my y-intercept, which comes out to 5. So when I'm writing my linear equation using those 2 specific points, here's my slope, here's my y-intercept. I already did all the work, and now I just have to write it into that equation form. So y equals my slope times x plus my y-intercept, or my y-intercept plus my slope times x. So now at this point, I'm going to answer question 2, and it says, predict the total fat in a burger with 20 grams of saturated fat. Now if I look up here, the saturated fat was my x value. So I'm going to plug in the number x into my equation. Or sorry, the number 20 into the x for my equation. So I'm going to have y equals 2.34 times 20 plus 5. Now I could have used the second equation as well. It'll come out to the same value. And then in this case, I do want to multiply before I add. So I'm going to do 2.34 times 20. That comes out to 46.8. And then I'm going to add on 5 more. And that comes out to 51.8. So when I have 20 saturated fat grams, I can expect a total of approximately 51.8 total fat grams. Okay, now if I try it on the graph, I need to actually go back up and look for the value of 20 on the x-axis. So I'm looking here, and I'm going to look up to estimate where my line is, and then I'm going to look over. And it looks to me to be about 50. Now when I use the equation, I came out to 51.8. So that's really close. It's a little bit difficult to use the graph to estimate because not all the actual data plots are on that particular line. It varies between hamburgers. And this line was created using 2 specific points. So it's not exactly perfect, but it just gives us a rough estimate. Alright, in step 3, it asks us to predict the saturated fat when we know the total fat grams. Now total fat grams are our y values. So I'm going to replace y with 50 and then plug in our equation again of 2.34x plus 5. And in this case we want to do a t-chart. So the first thing I would do would be to subtract 5 from both sides. 2.34x drops down, and on this left side I have 45 left. Now the 2.34 is being multiplied by the x, so the opposite of multiply is to divide. And then I would know x, and x is how many saturated grams of fat. I'm just going to take my calculator and take 45 divided by 2.34. And it doesn't come out to a very nice number, so I'll have to make sure that I round it nicely. So I get about 19.2 grams for the saturated fat. So again, this was total fat, so that was our y value. I just plug it in for y, do a t-chart, and this would be saturated fat. Now if I check this, going back on the graph, I'm going to look for a height of 50. Now we already saw a height of 50 here, and when I trace it back down, it was approximately 20. Well, we got 19, so that is almost correct as well. So approximately 20. And this will be the practice that we do for this section of homework.